Okay, Chapter 6, Section 1 and 2, Adept level. We're going to talk about rates of change, which I mentioned briefly in the last video. So we have two scenarios here. We have a graph with two lines. These are actually called rays because they have a starting point, but they go on forever. So they represent two quantities. We don't know what they are, and we don't need to know because all it wants to know is which quantity is faster or slower and increasing or decreasing. So we're just going to compare the two. So if we look at quantity A, that's this line, would you say it's faster or slower? Well, obviously it is much steeper than line B. So okay, quantity A is definitely faster. Is it an increase or a decrease? Well, it's obviously an increase because the graph is going up. Okay. Let's look at quantity B. Okay. It is obviously slower. Okay. Is it increasing or decreasing? Well, it is an increase as well. Okay. So they're both going up, but at different rates. Let's look at the next graph, quantity A and B. Quantity A, which one's faster? Okay, well, quantity A is steeper, so it's faster. So I can actually go down right now to quantity B and say that it's slower. Okay, but when it comes to increasing and decreasing, well, they're both the same. Okay, they are both going down, so they are both decreasing, but of course at different rates. All right, let's look at a situation. We have a sample of bacteria with a limited food supply, and it's allowed to grow. Which graph best describes the bacteria's growth over time? All right, so we have three possible scenarios, three different graphs describing the situation. So let's look at graph A. As time goes on, the number of bacteria, okay, in the sample increases. But notice how this line is straight. Whenever we have a graph of a straight line, we say that the rate of change is constant. So bacteria increases at a constant rate. And you're going to see all this again and again, so just introducing it to you now. Graph B, as it begins, the graph actually starts to go down. So it's like bacteria starts to die, and then they stop dying, and then they start multiplying again. So bacteria decreases and then increases at a blank rate. Well, we can't say constant because this is not a straight line. Okay? Hence, the rate of change, it's not constant like this. It varies. So we say it's a variable rate. So the graph is curved. There we go. And the last scenario, scenario C. Okay, bacteria increases at a constant rate because the line is straight. But then it levels off. Okay? So the number of bacteria does not change with time. So the line is horizontal. And then decreases at a constant rate. And we can say constant because that line segment is straight. All right, so which scenario best describes our situation? Well, I would say graph C. Okay, I think it's obvious we can rule out B. Okay, but the reason why C is a better description than A is because in the question it states that there is a limited food supply, which means eventually it's going to run out. So once the food supply runs out, the bacteria can't grow anymore, and then eventually they will start to die off. Okay, so that is clearly shown in graph C, whereas graph A just shows the bacteria growing and growing and growing and growing and growing. All right, so here at the bottom, let's summarize. Bacteria depends on time. Okay, and that should make sense to you. It wouldn't make sense to say the time depends on the number of bacteria there are. Okay, so like in the first video, the bacteria depends on time, therefore it is the dependent variable. It's the dependent quantity. Well, time doesn't depend on anything, so it's free. Hence, it's independent. And again, we'll talk about dependent and independent variables again.